We talk about IP addresses all the time, right? But here's a little secret about networking. Data doesn't actually travel between them. Nope, it moves between physical hardware addresses. So, how in the world does your computer translate a logical name into a physical location? Well, that's the magic of ARP, the Address Resolution Protocol. Think of it as the invisible broker that makes your entire local network actually work.
All right, so here's how we're going to break this down. First, we'll tackle the fundamental problem that ARP was born to solve. Then we'll see how it works as both a brilliant solution and a killer diagnostic tool. We'll also have to talk about its security flaws before getting into a super practical trick for finding devices that have gone missing. And finally, we'll wrap it all up with why this old school protocol is still so incredibly important today. So here's the thing. Every single device on your network is kind of living a double life. It has two addresses, which creates this core dilemma. One is the logical IP address that tells you who a device is, but the other is the physical MAC address, and that tells you where it is. To send even a single packet of data, your network has to know both. The best way to think about it is like this. An IP address is like a person's name, say John Smith. It identifies who he is. But the MAC address? That's his physical street address, 123 Main Street. It's where you can actually go to find him. See? One is just a logical name, the other is a real physical location.
This quote just nails it. Trying to send data with only an IP address? That's exactly like putting a package in the mail addressed to John Smith with no street, city, or zip code. It's just not going anywhere. So networks absolutely need a system to look up that physical address using the logical name.
So how does the network solve this problem? Well, this is where our hero, ARP, steps onto the stage. It is the protocol designed specifically to be that broker, connecting the logical world of IP addresses with the physical reality of MAC addresses.
Okay, so what is ARP really? At its heart, it binds those two network layers, the logical layer 3 and the physical layer 2. When your computer wants to talk to another device in the local network, it basically broadcasts a question to everyone. Hey, who has the IP address 192.168.1.10? The device with that IP then replies directly saying, yo, that's me, and my physical MAC address is, and just like that, a temporary dynamic map is created so they can talk.
But look, ARP isn't just some abstract theory. For network engineers, IT pros, controls engineers, it's an incredibly powerful forensic tool. You can actually peek into this network phone book with one dead simple command. This is it, the magic command ARP-A. Typing this into your command prompt or terminal opens up the ARP table. That's your computer's short-term memory of which IP address belongs to which physical MAC address right here on your local network. It's like having a secret window into the physical connections happening all around you. And this is where it gets really, really useful. Let's say you've got a new camera or a PLC online, but you have no idea what its IP is. Just check the ARP table. Are you worried that two devices are fighting over the same IP address? The ARP table will show you that conflict plain as day. And hey, before you waste hours troubleshooting some complex routing issue, a quick ARP-A can tell you if you can even physically see your gateway. It's an amazing first step in any diagnosis. Now, for all its brilliance and utility, ARP has a pretty big dark side. See, it was designed in a much simpler, more trusting era of networking, and that original design has created a major security gap in pretty much all modern networks. Here's the core of the problem. ARP is built for speed and efficiency, not security. It just trusts any device on the network, no questions asked. When a machine claims, hey, I have this IP address, ARP just believes it. There is zero authentication, none. And that blind trust is so easy to exploit. In what's called a man-in-the-middle attack, a bad actor's device simply lies. It tells your computer that it is the network gateway. And because ARP is so trusting, your computer starts sending everything, passwords, emails, all your sensitive data, directly to the attacker. It's a frighteningly simple but devastatingly effective hack. Thankfully, we do have ways to fight back. Modern network switches have features like dynamic ARP inspection, which basically acts like a security guard, validating ARP messages before it trusts them. This usually works hand-in-hand with something called DHCP snooping, which keeps a log of legitimate IP to MAC pairings. And for your really critical devices, like servers, you can just create static, permanent entries in the ARP table that can't be poisoned. Okay, let's switch gears from security back to a really powerful, practical use case. Imagine this. You just plugged in a new industrial controller, or maybe a headless IP camera. You know it's on the network somewhere, but you have no clue what IP address it grabbed. ARP is your new best friend here.
Here's a super cool 3-step trick to find it. First, you're going to ping your network's broadcast address. This is like shouting hello in a crowded room. It forces every single device on the local network to respond. Second, right after you do that, immediately run ARP-A. Because everyone just replied, your ARP table is now fresh and full of active devices. The last step, just find your device in that list.
And how do you identify it? Well, here's the secret. The first 6 characters of any MAC address are called the Organizational Unique Identifier, or OUI. It's basically a code assigned to a specific manufacturer. So if you're looking for a Siemens device, you just scan the list for a MAC address that starts with 000105. It's like finding a device by its unique fingerprint.
So after all this, why does a protocol this old still matter so much? Because really understanding ARP as a tool, a problem solver, and a security risk, it forces us to look past the surface and see what's really happening on our networks at the most fundamental physical level. And if there's one key thing you have to remember when you're troubleshooting, it's this. The ARP table is volatile. It changes. The entries expire, sometimes in just a couple of minutes. This means timing is absolutely critical. You have to grab that information while it's fresh. At the end of the day, mastering ARP isn't just about learning a command. It's about understanding that critical dance between Layer 2, the physical highway of your network, and Layer 3, the logical roadmap of IP addresses. Once you truly grasp that relationship, you can solve problems that leave everyone else totally stumped. So the next time a device seems to just vanish off the network, don't jump straight to the firewall or the router. Start simple. Check the ARP table. It might just surprise you. And that leaves us with a question to think about. What's the most unusual network issue you've managed to solve with this one simple command? Thanks for joining this explainer.